Good afternoon, everyone. Good afternoon, everyone. This is Dr. Ayesha.Butalia. Today, we are going to talk about the testing conventional applications. We have already covered the basics of software engineering, that is software project life cycle. And we have our requirement gathering. Then second phase is your analysis. Third is your design. Fourth is your testing. Fourth is your coding and implementation. Fifth is your testing. And sixth is your maintenance. Maintenance is only for the long-term projects. Short-term projects, you can avoid the sixth phase, that is maintenance. So the fifth and the most important phase, which generally IT professional ignores, and that is testing. Especially when you are a student, this is the most neglected phase of a project life cycle, that is testing. But testing is a very, very important task. Sometimes you go to your teacher and you show your report or maybe your paper. Okay, you have just written the report. You never go and take a printout and check it. When you take a printout and check it, you will see that you can see more mistakes in a hard copy. You get that? Which is not feasible when you are seeing a particular document on a mobile. That is least you can see your errors. If you see your document on a laptop, then also it is fine. But the most visible thing is, before you go to your faculty, you should take a printout and check it, because that's the most easiest way to test your errors. Whether you have done some mistakes in your spelling, in format and everything. But you miss it. And then when you go to the cabin, you have been told about some spelling mistakes, font, this, that, which is not actually to be told. The focus of the faculty should be on the content. But since it is not presentable, the things are unnecessarily deutilized energy somewhere on the unimportant things. Similarly, in your project life cycle, sometimes you are spending too much time on your coding, but you miss out your main objective. And that is only achieved when you do the testing. When you do the testing after, say, 1 year, okay, you come to a disaster when you say that, oh, my outcome is totally wrong. So what you have to do? You have to do reverse engineering, start from the scratch. Maybe you have to start from requirement gathering. Maybe you have to start from analysis. Maybe you have to start from design. Maybe you have to do editing in the coding. If there is an editing in the coding, it's fine. But if you need to change the design, then it's a big disaster, let me tell you. So what today the testing strategy says that you should test after every phase, in fact. So today, testing is not on the fifth phase. It is in fact after every phase. So after requirement gathering, there should be a testing of the data. So client should sit with you after every initialization of the second phase and completion of the previous phase. So after you get your analysis done, test it. After you get the design done, test it. After you do the implementation, test it. In a very rare case, then it will happen that you need to change the design after the coding part. Okay, so that is called as incremental testing. So testability, what are the features? Why do you do the testability? For more operability. It operates cleanly. Observability, the results of each test case are readily observed. Controllability, the degree to which testing can be automated and optimized. Okay, you need to have control, right? You can't say that after implementation, you suddenly go to the analysis phase. That means you lost the control in between. Okay, decomposability, testing can be targeted. So we are decomposing it into phases. We can even have different people working on different modules. So if there are 5 modules, if there are 5 modules and say 5 people are working on all the 5 modules, so those modules will be tested by those 5 people. So testing would be more faster because of decomposability. Last time we had discussed about object-oriented metrics using normalization for database. So in database also, if we decompose the tables, we can do testing on different tables parallelly. Do you get that? So if suppose 5 days is required to test one table and 5 people are doing parallelly, So total also you will require 5 days only. But if only one team is performing that testing, then 5 into 5, 25 days will be required. Okay. So if you decompose your tables and you distribute it among different human resources, then your things can be done parallelly in terms of coding also, in terms of testing also. So the same features which we have discussed till now about every process model, the same model you have to apply for testing as well. If you remember, we had discussed about V model, validation model. Validation model was totally for testing only. So while sharing this video on YouTube, I will be sharing that lecture on V model, which was explicitly for testing. Please go through that, revise yourself so that you know what are the features required for designing a process model for testing purpose, to execute a testing phase. Are you getting my point? Okay. So similarly, simplicity is maintained if you reduce complex architecture. Obviously, if you do your programming as per object-oriented design, the complexity decreases. Okay. Similarly, if you do programming on your module wise, so again आपका जो डिपेंडेबिलिटी है वो जरूर बढ़ जाएगा, लेकिन आपका जो टास्क है वो जल्दी अचीव होगा. आपका डिस्ट्रीब्यूटेड अप्रोच से सबकी एक्सपर्टाइज भी आप उसमें ले सकते हो. फॉर एग्जांपल, इफ अ पर्टिकुलर प्रोजेक्ट हैज 5 एक्सपर्ट डोमेन्स, so you can distribute it among 5 human different resources, because one person you can't expect that person can handle all the experts. Stability, of course, it will increase with testing on every phase. And of course, the understandability of design will be more confident when you do testing on that. क्योंकि जब आप टेस्टिंग करके आपको आउटपुट मिलेगा तो आपको उस डिजाइन की वैलिडिटी तुरंत पता चल जाएगी. Is that clear? So what is a good test? A good test has a high probability of finding an error. So the more errors you detect at an early stage, that is a good test, because the error should not come on the client side while running it live. Is that clear? So the more the errors, you should be happy about it, that you are going to solve it right away. A good test is not redundant. Redundant means it should not repeat. आज एक error solve किया, वापस वही error आ रहा है. That means you did not rectify it from the root. A good test should be best of breed. Okay, so that it has all the inputs. Breed means all the inputs should be available to rectify that error. So you need to find out those resources. You can't just skip it कि हम वो बाद में करेंगे, क्योंकि वो बाद में करेंगे तो फिर आपको रिवर्स इंजीनियरिंग में बहुत पीछे जाना पड़ेगा. Clear? A good test should be neither too simple nor too complex. I think anything should be like that only. Even when we design a paper, question paper, okay, we have been told that there is a mathematical model to even design a paper, and that's a normalized curve. What's a normalized curve in probability theory? That the normalized curve is an exponential curve where very less people should fail, because it's a low curve here. I can show you on the screen as well. So this is the graph, if you can see. So here the paper should be set in such a way that it should not be very difficult. If it would be very difficult, more people will fail. So we want less people to fail here. We want less people to score high also, because it should not be very simple also. So the paper should be set in such a way that maximum people should have average marks. So only those who have not studied at all will fail. So that is justified. And those who have done extra efforts will only score very high. Clear? So this is your score. You get that? So even a question paper should not be very simple, and it should not be very complex, as per what has been, because we have been university setters in Pune University, where we are ruled by 250 colleges. So we can't do a paper set very simple where everybody scores 90%. People will question mark us. And if we design in such a way that it's very difficult, then also it is not good. because everybody is failing, that is also. So we are designing in such a way that it should satisfy the normalized curve. I hope you get this. Okay. I always recommend that please ensure that you write some highlights of every lecture, so that when you next time, it's not possible to recollect the entire 45 minutes lecture. So your highlights would be very, very handy to you to revise this topic and get connected, because this may be a longer topic. We may require a couple of sessions. So to have a continuity, please ensure yourself with writing with some highlights. So next is internal and external view. Any engineered product can be tested in two ways. How is that? Knowing the specified function that a product has been designed to perform. Tests can be conducted that demonstrate each functional is fully operational, while at the same time searching for errors in each function. Okay, so the first paragraph, it says that you have to test function wise. And the second paragraph says that you have to test product wise. Is that clear? So I say that you do both. First you do function wise, then you integrate all the functions, and you have to do the product wise testing as well. Clear? So there are two ways, internal and external. Internal means all functions. External means the entire product. So I think you know all this. The only thing is you do not know the terminologies. Right? You want me to repeat it? Okay, the audience saying no. So the test case design. Bugs lurk in corners and congregate at boundaries. What does that mean? That the errors are somewhere in center and in boundaries. So for boundaries, it is very easily to locate. That you will be locating through product, but central you will be locating through functions. So internal is function oriented testing, external is your boundaries testing. Is that clear? But both are important. So objective is to uncover and however it is, whether you do external or internal, your objective is to uncover the errors. That means uncover means to find out. Once you find out, then only you can solve. So criteria is to in a complete manner. Complete manner means through internal and through external. And constraint is with minimum of effort and time. Testing cannot be infinite. So always, if implementation requires 1 year, testing should not go than more 1 month. So it is less time and effort to be required. That's a graph. Now, what is exhaustive testing? Exhaustive testing in one word actually is line by line. It's line by line. Means यहाँ पे अगर आप पूरा flow chart देख रहे हो, तो हर flow पे उन्होंने test किया है. That's called exhaustive. इसलिए exhaust हो रहे हैं ना, तो नाम से ही समझ में आ रहा है. Line by line testing हो रही है आपकी. तो अगर loop 20x है, तो वो loop 20x बार चलेगा, हर बार वो error आपको देखना पड़ेगा. So there are 10 to the power 14 possible paths. अगर इस particular graph को आपने देखा तो. So if we execute one test per millisecond, it would take 3,170 years to test this program. So do you think exhaustive approach is a feasible approach? No. For short programs, it's good. अभी तक आप testing करते थे, लेकिन वो छोटे program पे करते थे. Why testing is a part of software engineering subject? Because it itself is an expert domain. People are hired as STQs in industry. And that's a special section. And trust me, that's the most respectable, highly paid and less work. क्योंकि आपको सिर्फ टेस्ट करना है. लेकिन आपके टेस्टिंग पे ही उनकी सारी मेहनत डिपेंड करेगी. तो इसीलिए STQs are in highly demand, but STQs are less people required. Well, that's a 1 month job. Implementation is a 1 year job. So you have to qualify yourself with good certifications and good knowledge to become an STQ engineer. But once you get that, then trust me, it's the most worthwhile opportunity to deal with. and lot of foreign opportunities with STQAs because you have to directly communicate to the client for testing purpose on the client end also. So that people are sitting at both ways. They are interface between your and the client. And generally, we people are working for the outsourcing for the abroad industries. So that is why they are more keen to go. They are more required to go abroad. And they have more opportunity to sit with the client as well as both. So that's why more recognized. Okay. So selective testing. In selective testing, we will only select a particular module. So if we understand by a particular loop कि गड़बड़ यहाँ पे है, तब उसको उतना ही exhaustive approach करो. समझ में आपको? अगर suppose 1000 lines का कोड है और 20 lines का एक मॉड्यूल है और आपको पता चला कि इस मॉड्यूल में ही मुझे डिफेक्ट दिख रहा है, तो आप उसी 20 lines को exhaustive approach में जाओ. So still you will do exhaustive approach but on a particular selective module. Simple to understand. Theory concepts of testing is very simple to understand. Difficult is that you have to identify tools to do exhaustive testing, tools to do heuristic testing, tools to do selective testing. Clear? So software testing is of two types, white box and black box. So nothing to worry. In simple language, I'll tell you, white box means coding testing. Coding means line by line. And it is done on the client side. Okay. So basically, white box testing is identifying of defects. Defects, I had told you in one of the online lectures, we had discussed about testing also in detail when we had discussed about SDLC, Software Development Lifecycle. I hope you remember that lecture. We had discussed what is the difference between defect and error. Defects are the mistakes done at the designers and the coders side, whereas errors are the mistakes which are identified at the client side. So similarly, white box testing deals with the defects. That means deals with the design and the coders, whereas black box testing deals with the product and at the client side. Clear? If you are not able to digest the concept too fast, please go through this lecture, okay, at least 2-3 times. I'm pretty sure that the concepts are very simple. You'll get connected. So white box testing, we have to see why it is showing a lens here, because we have to do line by line the coding part. And loops, why the flowchart is shown, because flowchart ke baad hi coding aata hai. So you have white box testing is nothing but your design and the coding. And it has to be done in minute detail. Why cover logic errors, incorrect assumptions? Then we believe that the path is not likely to be executed. अगर आपको लगता है कि flowchart यहाँ से जाने से wrong output दे रहा है, turn the path. That is, you have to find out when you see that output is not expected. So that all you have to change the design. Obviously, the client is not going to change the design. So you have to do using at the coder side during white box testing. So obviously white box testing will have typographical errors, which you have done some mistake, syntactical errors, some logical errors, some incorrect assumptions. Is that clear? कई बार आप कुछ default value set करते हो, अगर आपने वो गलत सेट किया तो आपको आउटपुट गलत मिलेगा. तो ऑब्वियसली ये तो कोडर ही ठीक करेगा. तो इसलिए ये सारी जो भी एरर्स है ये व्हाइट बॉक्स टेस्टिंग में कवर होती है. नाउ यू टेल मी, पाथ टेस्टिंग, will it come in white box or black box? Path testing, will it come in white box or black box? White box, क्योंकि it is always connected to the coding. Clear? Cyclomatic complexity, what is that? Before that, just go through this. First, we compute the cyclomatic complexity, number of simple decisions plus 1 or number of enclosed area plus 1. So how many graphs you are having here? If you have learned data structure, this is nothing but a graph. And what is cyclomatic complexity? If you have a loop, then probably you are stuck up somewhere. You have to bifurcate, cut that loop and get it into two graphs. Is that clear? Because loop can create deadlock. What is deadlock? It is a concept of operating system. You are waiting for one resource from me. I'm waiting from one resource to you. You also keep on waiting. I'm also keep on waiting. And nobody executes the process. That's called deadlock. So there should be no loop in your graph, in your this path. ये जो भी यहाँ पे हमने जो डायग्राम दिखाया है, इसमें कोई लूप नहीं होना चाहिए. लूप हुआ तो डेडलॉक होता है. तो इसका क्या करना है आपको? डेडलॉक अगर हुआ तो आपको ब्रेक करना है. ब्रेक इनटू टू पार्ट्स. इज दैट क्लियर? तो यहाँ पे कितने पार्ट्स दिखाई दे रहे हैं आपको? एक यहाँ पे 1, then 2, then 3 and then 4. So there are 4 path. अगर आपने ग्राफ थियरी पढ़ी है तो ग्राफ क्या होता है? द एजेस and the vertices. So how many edges? How many vertices? 1, 2, 3, 4, 5, 6, 7 vertices. And how many edges? 1, 2, 3 and 4. So there are 4. That means V of G is equal to 4. That is why V is for vertices, G is for graph. So this is nothing but a graph. What is a graph? Which has vertices and edges. What is a tree? Tree has a root node and it has siblings and it has got a child node or a leaf node. A tree is also a graph. Yes, but tree cannot be closed. If a tree becomes a closed, it can be a graph. Is that clear? So these concepts, obviously, you have to check out of your data structures. You can go through my online videos also on graph and tree. You will understand. So what does cyclomatic complexity says? A number of industry studies have indicated that the higher the VG, the higher the probability of errors. Why? क्योंकि जितना ज्यादा edges होंगे उतना ज्यादा आपको टेस्टिंग करना पड़ेगा. उतना ज्यादा टेस्टिंग करना पड़ेगा तो उतने एरर्स भी आपके निकलने के चांसेस ज्यादा होंगे. कल हमने ओपन डे रखा था. हमने 100 शीट सपोज डिस्ट्रीब्यूट करी. 100 शीट डिस्ट्रीब्यूट करी तो प्रोबेबिलिटी ऑफ पीपल हैविंग एरर्स वुड बी मोर. अगर मैंने 20 शीट्स डिस्ट्रीब्यूट करी होती तो प्रोबेबिलिटी ऑफ हैविंग एरर्स वुड बी हैव लेस. इट इज एज सिंपल एज दैट. The more the data, the more the complexity. The more the complexity, the more the chances of having errors. So what is cyclomatic complexity? The higher the VG, the higher is the probability of errors. It is very simple concept. The only thing is you do not know such higher terms. You have not heard about what is cyclomatic complexity. Is that clear? So that is why software engineering subject, as I told you initially, it is the most easiest subject. What you have to learn in this subject is just these terminologies. Okay? Because whenever you are writing SRS, you have to use these complex terms. That's it. Otherwise, a layman, even a 10th class children, even 4th class child can make an SRS. You have to just understand a problem statement. That's it. Even writing a 2 + 2 4 is a problem statement. They are designing some toy nowadays in 4th standard using robotics. That's a problem statement. So even they can write SRS. The 6th standard people are learning C language. 7th standard people are using Prolog, Python. 9 students are learning Python. So they are learning AI. So even they know how to write SRS if they knew these terms. But the only thing is they do not have software engineering as a subject. So they do not use terms. Otherwise, there's not a simple, like this subject is at all not a very complex subject to deal with. So again, basic part testing. Now see, what are the 4th path? Can you check that? So path 1, what is 1? This is 1, this is 2, this is 3, this is 4. So you can number this path and you can yourself see that you can have different path over here. Okay, so this I give you an exercise that you have to number yourself. I have not mentioned it over here. You have to do it as an exercise. कि आप ये notes को 1, 2, 3 define करो और वो path identify करो. Why it is 8 over here? 1, 2. See, आपको clearly दिख रहा है 8. 1, 2, 3. Is it visible? This is 4. This is 5. This is 6. This is 7. What is 8? 8 is the end. Clear? Start is not an issue क्योंकि हम 1 से start कर रहे हैं तो 1 से ही start होगा. Okay? But यहाँ पे 2 loop आ सकते हैं ना. 7 के बाद 2 loop आ सकते हैं. इसलिए 8 को end रखा है और 8 को यहाँ पे mention किया गया है. Any doubt? Should we go further? Yes, please do at his homework. Now this 1, 2, 3 is also visible. You have to identify this path. You have to do this. Can you have another path? You also check it out. Don't just blindly go through by the PPT. Okay, so why you have learned flowcharts, now you understood? Is it easy to do testing on coding? No. You have to do exhaustive testing and we say that it's not feasible. So we have to do testing on the design, which we are learning as your software engineering. So you have to test on the design. So for that, you should have the flowchart. Understand? So you should know how to use the graph. So now you might have understood why did you learn graph theory in your data structures? Because graph theory is the base of testing. So you might not ever use a graph for your coding purpose. You might use trees, you might use linked list, you might use stacks, queues, arrays, etc. You never use graphs, but you use graphs in testing, which is very important. So summarizing, using design or code as a foundation, draw a corresponding flow graph. You understand now the importance of design? Determine the cyclometric complexity. What is cyclometric complexity? Calculate the vertices and the edges. Calculate all the path and see if there is a deadlock. If yes, break it. If not, identify all the possible path. Determine a basic set of linearly independent path. कुछ dependent path होंगे, कुछ independent path होंगे. Prepare test cases that will force execution on each path in the basic set. So now what is test case? If there are 4 paths, how many test cases आपको बनाना है? 4. और उस test case में क्या होगा कि आपने सारे permutation combination उस path को test कर लिया है. क्योंकि अगर 4 path का आपने एक ही path test किया तो client के उधर अगर 3rd path पे issue आएगा तो आपसे miss हो जाएगा. And you can't take that chance. So it is testing is very technical. अभी तक आपको क्या लगता था? किसी स्टूडेंट को बिठा दो, बोलो मेरा प्रोजेक्ट टेस्ट कर लो. No, we are talking here that you have to test after every phase of your SDLC, after requirement gathering, after analyze, after test design. So every phase you will have a flow graph. Every phase you will try to identify cyclometric complexity, and on every path you will create a test case. Is that clear? So finally, if there are 4 paths, there will be 4 test cases, and it will mention that you have tested that path with all permutation and combination. So what is a graph matrix? A graph matrix is a square matrix whose size, that is number of rows and columns, is equal to the nodes of a flow graph. I want you to just read it. So you might have learned about 2D matrix and 3D matrix in your 12th standard, okay, or maybe in your higher school. So a 2D matrix is 2 by 2. That means 2 rows and 2 columns. 3 by 3 is 3 rows and 3 columns. When we say n by m, that means n number of rows and m number of columns. So you have to match that with your graph matrix. So graph matrix is a square matrix whose number of rows and columns is equal to the number of nodes in a flow graph. So if there are 4 nodes, हमारे पीछे वाले एग्जाम्पल में देयर वर 8 नोड्स, सो हाउ मेनी 8 by 8 का ग्राफ मैट्रिक्स बनेगा? इज दैट क्लियर? Okay, so each row and column correspond to an identified node and a matrix entries correspond to connections. So what are the connections? They are the edges. By adding a link weight to each matrix entry, the graph matrix can become a powerful tool and evaluating program control structure during testing. So if we have 8 nodes as per previously, so there would be 8 by 8 का matrix. Right now, just let us stick to only 3 by 3 का matrix. So here, what you have to do, there are 3 nodes in the graph. That's why it is 3 by 3. Every entry should have a weight assigned to it. Every entry should, so you can attach a weight to every node over here. And why that is required? So that you understand कि इस नोड का कितना इंपॉर्टेंस है. अगर आपको लगता है कि ये पाथ जो है इस पर्टिकुलर कोडिंग में इतना इंपॉर्टेंट नहीं है, तो उसको आप कम वेट असाइन करो. इज दैट क्लियर? देयर आर सर्टेन लूप्स व्हिच आर वेरी रेयरली यूज्ड. जैसे अगर आपने स्विच केस यूज किया होगा, कभी मेनू ड्रिवन प्रोग्राम किया होगा सी लैंग्वेज में, certain conditions are never used. You just keep it for formality's sake, for rare conditions that you can assign it as a less weight. For example, if I got a roll call list and I have to assign certain database for every alphabet, okay, starting names with every alphabet, what do you think what Z will have? It will have least weight because the name starting with Z will be very minimal, but the name starting with A are maximum if you have observed. So हमें A के नाम को ज्यादा वेट देना पड़ेगा और Z के नाम को कम वेट देना पड़ेगा. अब वेट क्यों देना है? क्योंकि हमने ये डिसाइड किया है प्रोग्राम लॉजिक में कि जिसका वेट कम है उसको डेटाबेस में कम डेटा असाइन करना है, जगह असाइन करनी है, क्योंकि कई बार आपको सेगमेंटेशन करना पड़ता है एज पर ऑपरेटिंग सिस्टम कॉन्सेप्ट. सो वी डिस्ट्रीब्यूट segments. For example, if there are certain classrooms in this college, so एक क्लास का सिटिंग अरेंजमेंट 20 है, एक का 10 है और एक का 100 है, एक का 50 है. So if you know that you have only PhD students 10 enrolled in this campus, in this department, so you will assign that particular classroom. अगर आपको पता है कि PG स्टूडेंट सिर्फ 20 इस डिपार्टमेंट में एनरोल्ड है, तो आप 20 वाला क्लासरूम दोगे. आपको पता है SC को 50 चाहिए तो SC को, आपको पता है फर्स्ट ईयर को 100 चाहिए तो फर्स्ट ईयर को. सो वेट्स आर असाइन्ड एज पर द रिक्वायरमेंट एंड कैपेसिटी एंड वी अलोकेटेड. प्रोग्रामिंग में हम क्लियर कर देंगे ME को यही क्लासरूम देना है, PhD को यही देना है. ये हम क्यों कर सकते हैं ऑटोमेटिकली? बिकॉज वी हैव असाइन्ड वेट्स एंड वी नो दैट these weights are assigned low because less number of students are admitted to that particular course. तो उसका एक लिंक रहता है. ऑब्वियसली ग्राफ में लिंक तो रहेगा ही, एज हमें क्या करना है, लिंक ही तो करना है. So that ways, okay. So control structure testing, you have two types. Conditional, you know, conditional is that diamond box in flowchart. So conditional will have yes or no. Okay, it cannot have anything else. Either the condition is true or the condition is false. So you have to follow that. So that's why Boolean in Java has only 0 and 1. Now you can set 0 as true and 1 as false or vice versa. That flexibility every programming tool gives. Data flow testing. So you can have conditional testing कि अगर ये yes जा रहा है तो बरोबर जा रहा है, कि no जा रहा है तो बरोबर जा रहा है. दूसरा कि आपको flow check करना है कि sequence 1 के बाद 2 is proper sequence or not. Is that clear? So this is simple. Okay. Now we will be discussing about the data flow testing. So what is data flow testing? I want to give you 2 minutes to read this out. Now, in the data flow testing, you have two modules. One is the definition and the use. So how to make you aware with this mathematical statement? Now this is S and S dash. What is S? S is the statement that contains the definition of X. Okay, and S dash is the statement which contains the use of X. X is the couple of code which you have to test. So that part of the code of X which is to be defined is S, and which has to be used is S dash. The best example I can give on this is to make you explain about the D, E, F of S and use of S dash is your structures. If you remember, in structure what we do, we have got struct S, suppose struct S, struct student, and we define. And then we declare an object. Suppose this is the definition, and then we say struct student S. So what is struct student? It is a definition. What is S? It is the object of the struct student. But still, till the time, suppose there is year, int roll number requires say 4 bytes. Okay. And character requires 1 byte. Say C, for example. Or you can say name, and it can be a character array. So character requires 1 byte. So character of 10 array will require 10 bytes. Roll number, 32-bit operators use 2 bytes in integers. 64-bit operator plus they use 4 bytes as integers. So suppose we are all using now 64 plus. So 4 bytes for roll number and 10 bytes for name. So 14 bytes is allocated for student. The moment we say S, an object is created of 14 bytes in the memory. Okay? So 14 bytes memory is allocated. And what is that called? What is that block of memory called? It is called as S. That 14 bytes of memory is called as S. Suppose I say struct student S1. Then another 14 blocks of memory will be allocated, and that will be named S1. The initial 4 bytes of that 14 byte block would be integer, to store integer. Next 10 bytes would be for storing character of 1 byte each. Is that clear? If I say struct student S2 of 9, then what will happen? 9 into 14, that much bytes of memory will be allocated. First memory will be named as S of 0, second S of 1, second S2, as on to S of 8. Do you get that? So this is how memory allocation is done. This is called as definition. So this is called as definition, and this is called as use. So you can scanf by using dot operator S dot roll number. So you can use scanf and printf in C language. So that is nothing but now you are using that object variable. So this is what definition. This is definition plus this is declaration, and this is use. Do you get that? Again, I'll repeat. This is definition, this is declaration, and this is use. So the same things here they have done with a mathematical model where S are the instructions which are to be defined. So that is the structure block. And S dash is the statements which are to be used. Yeah. So you have to identify that in flow testing. Why? Because the errors would be different. If there is an error in the definition, definitely there will be error in the use. So the flow graph says that first clear out the DF, then start the flow with the use. It's very simple. Actually, you know it. It's a common sense. But mathematically, since we are engineering students or we are doing coding, so everything has to be done in a formulative way. And hence we say that nothing without mathematics is perfect. So the same common sense has been drafted in a mathematical way. That's it. I hope this section is clear to you now. So what is loop testing? There is simple loop. There is nested loop. What is nested loop? Loop inside loop is a nested loop. What is nested if? If inside if. That is called as, okay. What is concatenated loop? Two strings combined, that is called as concatenation. My name is Ayesha, so I put string 1 as Ayesha, string 2 as Butalia. When I say strcat, if I use string functions in C language, we need to include #include string.h. So if I use strcat string 1, string 2, what will get displayed? ayeshabutalia. If you want space, then you have to put another column. Okay. So I've got a special lectures on string functions also, how to use standard string libraries, how to make your string functions. So you can go that also to the YouTube channel. But now here concatenation means combining two things. So there are two different independent loops. We are combining things. String 1 was different Ayesha, string 2 was different Butalia. That is two different strings. When we concatenate it, we combine the two independent modalities. But it has to be of same type. You always remember that. You cannot concatenate string and a float. You have to then write user-defined function for that. And what is unstructured loop? In any way. It is a combination of simple, nested, concatenated. All combinations is called unstructured. Okay. So testing of an unstructured loop. Now you might be thinking, why this topic here? Because it is as simple as that. The testing of a simple loop is simple. The testing of an unstructured loop is complex. Why? Because you have to find out the V of G multiple paths. From one VG, there will be 3 paths in an unstructured loop. So the permutation combination of test cases from one particular graph node will be multiples. You understand? In simple graph, if there are number of nodes is n, number of test cases would also be n. But in unstructured graph, you cannot identify if the number of nodes is n, how many test cases would be identified. You need to do all permutation combinations and find out. Clear? So simple loops, minimum conditions. Skip the loop entirely. Only one pass through a loop, 2 passes through a loop, m passes through m, loop m less than n. Okay, n minus 1, n plus 1. So we all know, we have done C programming, C++. So we all know how to use loops for while and do while. If you're not aware of loops, please go to the YouTube channel and see there are a couple of lectures on loops also. There is a particular video I have made. What is the difference between do while and while? You should understand as a programmer. You can't just blindly say that I can use anything. You should have to concentrate on the why. Why do while? Because in do while, first time any condition would be executed without even testing the condition. That's do while. In while, even the first condition, if it is false, the statements would never be executed. Okay, so if you are writing a menu-driven program, first menu should be displayed, so you better use a do while. For nested loops, obviously, I've also have couple of lectures on nested loops also, and I always say that the innermost loop should be solved first. If you are writing nested function inside function, function inside function, you can go through a video. I'll share it in the description box also. That how do you identify that this function has been completed and then the upper function should be executed? Because you maintain a stack. Stack means the innermost function address is at the last, at the up. तो जो सबसे बड़ा फंक्शन होगा उसका एड्रेस सबसे नीचे जाएगा, फिर हम दूसरे फंक्शन में आएंगे उसका एड्रेस ऊपर जाएगा, फिर उसका फंक्शन आएंगे ऊपर. I'll just share it with you like this. If there is a function, main function, and inside there is function 1. Then inside function 1, you have got function 2. Now what will happen? First, it is always function 2 which will get executed. If there is an error in function 2, function 1 will not work. This is the concept. I think you might have understood these fundamentals while doing programming. If not, please go through the video. I'll be sharing it in the description box. Entire logic has been explained how this works through stacks. So in stack, what will happen? The address of function 1 will be stored. Then upper would be function 1 and then उसके upper में function 2. जब function 2 अच्छे से पूरा execute हो जाएगा तो function 2 का address pop हो जाएगा, फिर function 1 का address आपको मिलेगा. इसका मतलब ये कि जब तक function 2 पूरी तरीके से execute नहीं होगा, आपका control function 1 पे जाएगा ही नहीं. That is why until and unless you complete this block, okay, you cannot go to the upper one. Same thing happens with your testing of your nested loops. So nested loop में भी जो सबसे innermost loop होगा, पहले उसकी testing होनी चाहिए, फिर उसके outer loop की और फिर उसके outer loop की. Do you get that? Anybody has any doubt why this should be done? Because if there is an error in the innermost loop, it will create an error for the outer loop, no? Because outer loop is independent to the inner loop. Inner loop is never independent of the outer loop. Always remember. Clear? So that is why for the simple loop, the approach is very simple in a sequential manner. In the nested loop, you have to just make sure while testing that please first take the flow graph of the innermost loop. If it is successfully, all test cases are created and tested successfully, then only create the test cases of the outer loop. Otherwise, you will be wasting your time. Okay. Same applies with the concatenated loops. So this was all about, we discussed about the white box testing today. In next session, we will be discussing about the black box testing. So just to have a quick recap, we are discussing about the testing conventional applications, and we already seen in couple of lectures why testing is important. What are the features of testability? What is a good test? What is internal and external? That means function oriented is internal, product oriented is external. Okay, what are the objectives of a test case? What is exhaustive testing? What is selective testing? What are the two basic types of software testing? And we discussed white box testing in detail. So whatever is white box testing is to find out logic errors, to find out incorrect assumptions, to find out defects in the path, to find out typographical errors done at random. Okay, so for that we understood what is cyclomatic complexity, what is basic path testing, what is derived testing, what is graph matrix, how to create graph matrix, what are the two types of control testing, what is the data flow testing with an example of structure, and what are the different types of loop testing. Because loops, conditions, they are a part of our coding, and white box testing is all about your coding testing. Okay, so we'll stop here. Thank you for your patience listening. This is Dr. ayeshabutalia signing off. If you have any doubts, you can post it on the comment section or on the WhatsApp group. Okay, and I'll be happy to solve your defects or errors, both. Okay, thank you very much once again.